All right, so here we are, lesson 9.1, conic sections. So we talked a little bit about circles last week. So you guys can see here the standard form for the equation of a circle. So we have x minus h quantity squared plus y minus k quantity squared equals r squared. H and k is the center, r is the radius. Pretty simple, pretty standard for circles. Okay, we're going to be learning about parabolas, ellipses, and hyperbolas in this chapter. So today's focus is going to be parabolas, which you guys have done a lot with in Algebra 2. I want to call your attention to the general form. Notice this is general form. It's not standard form, okay? Standard form, we're going to have each of the different equations for the different conic sections, but general form, they're all going to look the same. Here we have this equation, ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. Now, the majority of what we're going to be working with is going to have a bxy that's going to be a 0. So the b will be 0, and therefore that term will be eliminated. In section 9.4, we're going to see a bxy term that's not eliminated, and that's going to actually end up causing our conic to rotate. So let's see what you guys have for circles. All right, so example 1 and 2 here, just some examples for circles. So I want you guys to take a look at these and see what you think about those, and if you understand what we're doing here. Finding the diameter using distance formula, using midpoint formula to find the radius. So remembering midpoint formula and remembering distance formula. So you can pause the video, take a look at these examples and see if that makes sense to you. And then you guys did a parabola example for your homework. So here we have a parabola example. And so what do you remember from parabolas in Algebra 2? So let's take a look and see where you're at. Whoops. Scroll up here. All right. So this is the answer that you should have for the parabola for this example that you guys did on the homework over the weekend. So we have our vertex is going to be out as h comma k. Of course, when we have something like this, we have to complete the square first to be able to find our h and k. We know it's going to open down because the a value is negative. We can find our axis of symmetry because that goes through the vertex, so that's going to be x equals 3. We see our focus. Now the distance between the focus and the vertex is always going to be 1 over 4a, and it's always positive. So focus to vertex is absolute value of 1 over 4a from the equation. The vertex is equidistant to the focus and the directrix. So the directrix to the focus is also the absolute value of 1 over 4a, so that's 1/8. So you can see that the focus here, I took the vertex point 3, 2, and then I subtracted 1/8 since I know it opens down, so the focus has to be below the vertex. For the directrix, I added 1/8 because it opens down, so the directrix is on the opposite side of the focus, behind the parabola. Remember that the directrix is a line, so y equals 17/8. All right, the length of the lattice rectum, formula here, 1 over 4a, absolute value, and we get 1/2. All right, eccentricity is also equal to 1, and I'll talk about that in just a moment. So remembering what you learned from Algebra 2, here, to fill in all of these blanks, we can see that the definition of a parabola here, if I have my eraser, is a set of all points in a plane that are equidistant from a fixed line, the directrix, and a fixed point, the focus. So what you can see is that the 2 purple segments, those are congruent. The 2 green segments, those are congruent because we go from the focus to a point on the parabola and that same point to the directrix. And whenever we find that, we also want to make sure that we understand that these angles here are always right angles. All those right angles in there, because the distance is always a perpendicular segment. All right, so just check your blanks on this from the video. So here's our vertex form if our parabola is vertical or horizontal, and then things to remember. All right, there's one typo on the notes right here. The vertex is the midway, not the midpoint, because it's not actually a point. So the vertex is midway between the focus and the directrix. 5. You can pause the video if you want to take more time to look at this and fill in all the blanks. Also, I think I repeated that one twice. I'm not sure if I corrected that on your notes or not. All right, so eccentricity. Let me talk about eccentricity. So the eccentricity of a conic is the ratio of the distance from the focus to a point on the conic and the distance from that same point to the directrix. Well, the definition of a parabola just told us that that is equal. So since that's equal, when we find that ratio, we're always going to get 1. So the eccentricity of a parabola, no matter what, any kind of parabola, okay, a super wide parabola, a super skinny parabola, a parabola opening up, down, left, right, the eccentricity is always going to be 1. Okay. All right. So after that quick refresher, I would like you guys to do problems 3, 4, and 5 on the notes. So pause the video now, check out problems 3, 4, and 5, and then come back and check your answers. All right. So let's see how you did. So here's example 3. Take a moment to check that. You can pause the video if you need more time. Here we have examples 4 and 5. All right, so 4 and 5, these ones, they give us information. So here we're told that the vertex is 2, -1, and the directrix is y equals 1. So using that, I know that directly that my h and my k value are 2 and -1. Since the directrix is y equals 1, we draw that horizontal line. And since the directrix is horizontal, the parabola has to be vertical, up or down. And we know that the vertex is below the directrix, so that means our parabola opens down, which means that I know that my a value is going to be negative. Okay, so the work that I want you guys to show for these, you guys can do formulas like this. You guys can draw a sketch. Your sketch does not need to be on graph paper. It can just be a quick little sketch. You don't have to label everything. I like to put things like V and F and so on to help me and make sure that I understand what I'm doing. Okay. All right. So then something new that we're going to talk about here is the reflective property of a parabola. So let me go to my empty notes here. All right. So reflective property of a parabola. So what this says is it says it's a tangent line to a parabola at some given point. So if we remember a tangent line is a line that touches a curve in exactly one point. So here, this tangent line is only going to intersect the parabola ever at point P right there. And it's going to make equal angles with the following 2 lines. It's going to make an equal angle with, let me find my right pen, with the line passing through the focus and point P. So I can look here, the focus to point P, okay, that green one, is going to be congruent, and it's going to be the same, sorry, not congruent yet. It's going to make that same angle. So this angle here is alpha, right there. And then if I draw the segment from the focus to where that tangent line intersects the axis of symmetry, then that angle is also congruent, which means that this makes an isosceles triangle. All right. So since that's an isosceles triangle, we know that the green segment here is going to be congruent to the blue segment. And that's going to be really important for what we're going to do on the next example. All right. So one thing that I want to point out to you guys, because this is a common error that I see, is that, I have a highlighter here, that here it says the axis of the parabola. Okay, the axis of the parabola is the axis of symmetry. And so our textbook tends to only give us examples that are where the axis of symmetry is the y-axis. And so I don't want you guys to be confused that this axis is the y-axis. So this is not the y-axis. Okay. Also, if the parabola is horizontal, it's not the x-axis. Well, not necessarily. It could be if that's the axis of symmetry. So the axis of the parabola is the axis of symmetry. Oops. Symmetry. Oh my gosh, I can't even spell that right now. axis of, let's try that again. Oh, S-Y-M-M-E-T-R-Y. And my pen didn't even make an M. Okay, cool. All right, so that's the axis of symmetry. All right, so let's take a look at this example. This is brand new. I don't think you guys did this last year. So we want to find the equation of the tangent line to the parabola given by x squared equals 2y at the point 3, 9 halves. So I always first absolutely like to draw a diagram. So if I draw a diagram for this, let's go ahead and draw a diagram. We know that our parabola here is opening up, right? Because we have x squared equals 2y. So that's y equals 1/2 x squared. So I'm going to draw this. We also know that the vertex is going to be 0, 0. Okay? So our equation is y equals 1/2 x squared in standard form. All right. So vertex is 0, 0. Again, I'm just making a sketch here. So I could have graph the point like 1, 1 and so on if I wanted to. But it's not significant. Let's just go ahead and make a sketch. Okay, so what I have is I have a point that is going to be my point P. So the point that was given here, point P, oh, I don't need to call it point P, but I'll call it point P. You can label it anything you want. I'll use P so that it's easier to figure out and label the things as we're working. All right, so now I need to draw the tangent line from point P to the parabola. So here we go. Do my best to draw this tangent line. Oh, that's not too bad. All right, so there's my tangent line. Okay, let me shrink this a little bit. And let me extend my axis of symmetry, or my y-axis here, sorry. Okay, cool. All right, so what the reflexive property of a parabola says is that if I find my focus, the distance from the focus point, wherever my focus is, I'm going to label that F. So from F to P, so let me just label my F to P, change my color here. Purple. All right, so from F to P, that's going to be congruent to F to that intersection point there of my parabola. And let me go ahead and call that point, call that intersection point of that tangent line, point Q. So the distance from F to P is congruent to the distance from F to Q. Okay, so first thing we want to do is we want to find our focus point. So point F. Well, we know the x coordinate is going to be 0. The y coordinate is going to be the vertex, which is 0, plus the absolute value of 1 over 4a. So we look at our equation. We see that our a value is 1/2. So our focus point is 0, 0 plus the absolute value of 4 times 1/2. And close that parenthesis. And so we get our focus point is going to be 0, 1/2. Okay, so let me label that on my graph, 0, 1/2. And so now I know that the distance between F and P is the same as F to Q. So I need to figure out what is the coordinate of point Q, because I'm trying to write the equation of this green line. And if I have 2 points, I can just use point slope form to write my equation. So right now I know point P here. I need to find point Q. So let's calculate this length from F to P. And then we can use that length to figure out where the location of point Q is, since that's the same distance. All right, so F to P. So FP here, from F to P, we can use our distance formula. I don't know why I wrote that like that. That's weird. Okay, so we have the square root of 3 minus 0 quantity squared plus 9 halves minus 1/2 quantity squared, and we calculate that. So the length of FP, when you calculate that, you end up getting 5. So here, this length is 5 units, which means then that the distance between F and point Q is 5 units. And that's going to go straight down. So this length here is also 5 units. All right, let me scroll up a little bit to give myself some space. So now I'm looking for what's the length from, so FQ also equals, let me put that over here. Therefore, FQ equals 5 as well. Okay. All right, so now if I want to find point Q, I can find the length from F to Q. I'm just going to take point F. So point F is 0, 1/2. And I'm going to go down 5 units. So I'm going to subtract 5 from the y-coordinate. And when I do that, I get that, oops, hold on. I wrote that as FQ. I'm just trying to find point Q. So point Q. So that means that point Q now is at 0, -9/2. All right, so point Q, 0, -9/2. Okay, cool. And so now, since I have point P is 3 9/2, I have point Q here. I can use those 2 points to find the equation of my line. So equation of a line, point slope form. So y minus y1 equals m times the quantity of x minus x1. So in order to solve this and find the equation, I have either point P or point Q. So I need to find the slope. So let's go ahead and find the slope of PQ. To find the slope of PQ, I can do 9/2 minus -9/2 over 3 minus 0. And I get that the slope of PQ is equal to 3. So I can take that slope and I plug that in here. I pick either point F or point Q, and I just go ahead and plug it in. So y minus, and I'll just pick point, I'll pick point Q because it has 0 in it. So y minus -9/2 is equal to 3 times the quantity of x minus 0. And we tend to get these equations in slope-intercept form. So simplify this to slope-intercept form, and we get y equals 3x minus 9/2. And that makes sense with our diagram. And so there's the equation of the tangent line to the parabola given by x squared equals 2y at the point 3, 9/2. All right, but remember that this tangent line here, it doesn't always intersect the y-axis or the x-axis. It intersects this as the axis of symmetry. So that's very, very important. All right, so that's the end of lesson 9.1. And I will see you guys next time.